All right, so here we have a student that measure the heights and arm spans round to the nearest inch of each person in a random sample of 12 seniors at the high school. And here's a scatter plot of the data. So here are the arm span measured on the y-axis, and then the height is measured on the x horizontal axis. So part A, we want to describe the relationship between arm span and height for this sample of 12 seniors. Okay, so when you're describing a scatter plot, you want to make sure you address four things, and that's going to be the direction, outliers, the form or shape, you could say, and strength. So an acronym you can remember is DOFS, direction, outliers, form, and strength. So direction, we would say like there's a positive relationship because the values are increasing as one value goes up, the other one goes up. There aren't really any obvious outliers, so we could say something like that. In the form, we could say it's reasonable for it to be roughly linear. In the strength, we would say probably something around medium, moderate, that sort of thing. And then make sure you explain it in context. So our answer could be something like this. There's a moderate positive linear association between height and arm span with no obvious outliers. And it seems that taller students have longer arms. Pretty obvious. Does that make sense? Right now, let's look at part B. So here we have two graphs. And on graph one, we have the least squares regression line plotted, which is given here as y hat is equal to 11.74 plus 0.8247x. And graph two shows the line y equals x. So now let's look at what part B is going to say. So I'm going to move the page up so you can see the question and the graph together. Okay, so we have some criteria where they are going to classify people according to, through one of three body shapes. So they could be a square, a tall rectangle, or a short rectangle. Square would mean that their arm span is equal to the height. A tall rectangle would mean like that their arm span is less than the height. And the short rectangle would mean that their arm span is greater than the height. So if we're gonna, be classifying the people into one of these three groups, which graph would be more helpful? Using this least squares regression line or using the line y equals x? So let's relate arm span and height as the variables that they're represented as. So arm span, is the y variable. So y would be arm span, and height is the x variable. So if we say arm span is equal to height, that's like saying y equals x. If we're saying arm span is less than height, then we're saying y is less than x. And if we're saying arm span is greater than height, then we're saying that y is greater than x. So then graph 2 would be much more helpful for breaking people down into one of these three groups because it shows how the points relate to the line y equals x. For people that are going to be the square body type, they would be represented as points on the line. For people that would fall into a tall rectangle, there would be points below the line. There would be these points right here. That is y equals x, or y is less than x. And for a short rectangle, we're talking about the inequality y is greater than x. So we're talking about the values above this line. So graph 2 will be better. All right, so here's what like an explanation to part B could be. Probably doesn't have to be this long, but this basically just sums it up. Now, so if we want to figure out how many of the seniors are going to fall into the square body type or tall rectangle body type or short rectangle body type. For the square, we just count how many are on the line. So for the square, we would have 1, 2, 3. For the tall rectangle, points below the line. So 1, 2, 3, 4. And for the short rectangle, points above. So 1, 2, 3, 4, 5. And now if we're going to use the best model for prediction to calculate the predicted arm span for a senior with a height of 61 inches, the best model for prediction is going to be the least squares regression line. So the LSRL equation is this. So for this equation, we're simply going to plug in 61 for x and evaluate. So we'll get that y hat to be 11.74 plus 0.8247 times 61. You got a 62.0467. Make sure you show your work for these problems to make sure you get full credit. Also, make sure you use correct notation, so make sure you use y hat. Don't just put y, because sometimes they'll dock you if you put y, because remember, this is predicted y.